lesson of the unit. Okay, here's our big idea. Would everybody agree that 4 divided by 2 is the same as 8 divided by 4? You think so? Okay. Would you guys agree? 4 divided by 2 is 2. And 8 divided by 4 is 2. So they're both the same thing, just in different forms. Correct? You guys believe me? All right. How can we make them look the same? Okay, we multiply by a 1. So one we want to use happens to be 2 over 2, right? And that would make it look the same. So when the denominators are the same, the numerators must also be the same, right? Yeah. When the denominators are the same, the numerators would have to be the same, right? Isn't that true? You don't think so? I'm telling you, if the denominators are equal, the numerators are equal. They have to be.
Well, you're confusing me. This is like the first time we've ever heard this.
Okay, let's go back. Let me take this off for a second. Okay, let's take the words off the screen. Okay, does everybody agree that if I multiply the left side by 2 over 2, I get 8 over 4? And everybody believes that now that I have 8 over 4 is equal to 8 over, everybody agrees that's the same, right? I think it equals 2. So if the denominators are the same, the numerators have to be the same. They have to be. Aaron? That's because you had a variable involved. That's because you had a variable involved. And once that variable, that's what I'm getting at. That's what we're going to get at. So there's something that your 5th grade teacher never showed you. Okay? Right? You've been shown stuff like this, where if I have 8 over 4 equals x over 2, you've been shown that you can cancel here, right? You've been shown that, right? And you've been shown that you can cancel on this side too, right? Why can I not cross cancel on this? Because there's an equal sign. You can't cross cancel on an equal sign, right? If you cross cancel on an equal sign, you're going to make it unequal. You can't cross cancel. But what you were never shown, and I was never shown, I didn't figure it out until I became a teacher, is that I can cancel on each side of the equal sign. So I can, in fact, I can do that, right? And 8 equals 8. Do you know why I can do that? Because they're the same. I can remove them from the denominator. I can remove them from the numerator, right? You can do that. I can cancel this way. I can cancel this way. The only way you can't cancel, and it would work on this because they're the same number, the only way that you're not allowed to cancel is across that equal sign. Okay, so hold on, Aaron. So here's the reason why I can remove both the denominators. Because mathematically, what I'm really doing is I'm multiplying each side by the reciprocal. Right? Couldn't I multiply both sides of the equation by 4? No, I'm just multiplying by the denominator. Because I'm trying to clear the denominator. So I could multiply both sides by 4. That's why it mathematically works. So this is what we're going to do today. We're going to make our denominators match, right? We're going to find common denominators, and then we're going to remove the denominators because we're going to have an equal sign on each side. So today's no different from yesterday. You've got to make a common denominator, but today the only thing extra is we're going to have an equal sign in there. So we're going to actually solve for x. Before you were just simplifying, and you'd just have an expression, and you guys would say, well, am I done? And it was kind of abstract because you're like, I did all this stuff, I manipulated everything, am I done? And I'd say, yeah, that's it. Well, today we're going to actually take it one step further and solve. Yes, Aaron?
What would the math question be asking, though? Because I could have just said 3 was 2. What would make me say, oh, I'll just manipulate it and get rid of my denominator?
Coming up next. Next slide. Okay. The only reason I'm showing you this right now is because this is something simplistic that you can see. Now I'm going to add a variable into it. Okay? Make sense? You guys are always one step ahead of me. So, right? Now we're here. So now let's take a look at using variables. So where I'm getting at is if I can make these denominators match, then I know the numerators are equal. Correct? I just proved it to you with real numbers. Now I've got a variable in there. So what would I do to both sides to make this denominator match this denominator? Matthew? Multiply by 2 over 2. Right? I'm going to multiply by 2 over 2. So then I'm going to get 4x over 4. Correct? I'm going to write this out. So I'm going to get 4x over 4 equals 8 over 4. So technically, I could remove the denominators by multiplying both sides by 4 over 1. Right? Let's see if it works. All right, let's check it. So 4x's is equal to 8. So 4 times what equals 8? 2. Or we could do it just the classic way that we know how to do it. Divide both sides by 4, and I get x equals 2. What do I have underneath there? Anything? All right. So let's go back to my original equation. It wasn't 4x over 4. It was 2x over 2. So let's get rid of this. Doesn't really flow. Why am I having such a hard time finding things today? There we go. Okay. So our original was 2x over 2 equals 8 over 4. And I'm saying that x equals 2. So this is 4 over 2 equals 8 over 4. And doesn't 4 divided by 2 equal 2? And 8 divided by 4 equals 2? So it does work. So I've proven to you that if you have the common denominator, the same denominator, then what's also equal? The numerators are also equal. They have to be. If one is equal, if they are the same, if they look exactly the same, then the numerators are also equal. Kane? I can't hear the last part.
Why did you not multiply something by the right? If you want this to the left side of the equation, why not use this?
Because you're right. If you normally do something to one side, you have to do it to the other. But I didn't multiply. I didn't add anything. I multiplied by a 1. So you're allowed to multiply one side of an equation by a 1 because it doesn't change it. Does that make sense? It's just it's complicating it. It's unsimplifying it. Does that make sense?
Yeah.
Or if I wanted to in the very beginning, I could have uncomplicated the other side. Couldn't I have reduced this side by 2?
Yeah.
But see how I'm reducing it by a 1? So very good question. You can't add something to one side without adding it to the other, but I didn't add it. I didn't add anything to it. I just multiplied by 1. That's the only time you can. So then I would have gotten 2x over 2 equals 4 over 2. And now my denominators are equal, so I can get rid of them, right? And now I have 2x equals 4, so x equals 2. I still get the same answer. Okay? Are we good? Chris, it always cracks me up when you say we're good and your eyes are closed. Okay. But at least you shake your head like, I'm still listening. All right. So I'll be able to solve rational expressions and identify excluded values. So here we go. I'm going to start all the way on the right first. This is something that you're going to get. 1 over x minus 3 equals negative 1. Okay, we're going to solve that algebraically. But before we solve it algebraically, I'm going to show you how to solve it graphically. Okay? All right, I almost kind of want to solve it rationally first. I'm not rationally, algebraically first. I'm going to go with my instinct here. Okay, let's do that, because this is something that you guys would be more familiar with. So, they don't have common denominators, correct? So I'm going to create common denominators. So my common denominator, my only denominator, is x minus 3. So I need to multiply this side by x minus 3. So I'm not multiplying it by anything. I'm not adding anything to this equation. I'm multiplying it by a 1, correct? So now I have 1 over x minus 3 equals, now I've got to distribute a negative 1 right here times everything in the numerator. So negative 1 times x is negative x, and negative 1 times negative 3 is positive 3 over x minus 3. And what did I just tell you guys? When I've got common denominators, I have common numerators. The numerators are equivalent. So this actually can go away. All right, so hold on, I know exactly what you're going to ask me. So now I have 1 equals negative x plus 3. When I subtract 3 from both sides, I'm not going to skip any steps. Subtract 3, I'm left with negative 3 plus 1 is negative 2 equals negative x. Divide both sides by negative, and x equals 2. All right, so I just solved for x. I need to state what my excluded values are. X cannot equal what? Positive 3. X cannot be positive 3 because this can never be 0. No, x is equal to 2, but x could never be 3. Okay, 1 second. All right, so I'm going to take Kane's question first. Why is it still what? Why is it still 1 when you have a variable? I'm not understanding the question.
Well, like 2 over 2 is equal to 6, right? So if you have x minus 3, x over x minus 3.
That's still 1.
So why is it that you have a variable? So
Because the variable's the same. So even if the variable was 10, hold on. If it was 10, then wouldn't this be 10 minus 3, which is 7? And if x is 10, then x is also 10 here, which is 10 minus 3, which is 7, which is 7 over 7, which is 1. Does that make sense? That wasn't the question I thought that you were going to ask. Okay. No, I'm just saying I was wrong. Only when you check it. Okay. We ready? All right, I'm going to show it to you graphically. here's one. So remember back when we would solve absolute value equations, and I'd have, this is my original equation, and I'd split it up into two functions. The left side is one function. The right side is the other function. Do you remember that, how we did that? Okay, so that's what we're doing here. So I'm going to start off with, let's go with green. So I'm going to start off with this function. I'm going to graph, and this is a really good end of the unit exercise because this takes us back to our graphing, which you're going to be tested on next week, right? So I'm going to graph 1 over x minus 3, so what's my only shift? To the right 3. So I'm going to have an asymptote to the right 3. 1, 2, 3. Am I going to have a horizontal asymptote? It's just going to be on 0. So now I can graph this. Pretty simple. It doesn't have any type of stretch, so it's just here and here. My other function, what color do we want to make it? How about purple? All right, so my other function is g of x equals -1. So -1 is right here. So where do my two functions intersect? Where do they intersect? Right here, right? And what is x? So they intersect at 1 to -1. And what does x equal there? And x equals 2 here. Okay, so this is solving it graphically, or I could have said, okay, where do they touch? They touch where x is equal to 2, right there. X is equal to 2 right there. If I was solving for y, what would y be? -1, right? Y would be -1, x would be 2. Yes? The discontinuity is at 3 right here. The graph can never touch 3. But that doesn't involve the -1, right? That's only involved here, and that's why it happens to be the asymptote. So it's not a point of discontinuity because I never canceled the 3. It's an asymptote. Does that make sense? If I were to do something like this, then it would be a point of discontinuity or a removable discontinuity. It's going to be hard for me to break myself with that one. Okay, there's another way to look at it. All right, I could have, instead of making two functions, on this one I made, on the previous example, I made this a function of f of x, and I made this a function, I made this side g of x, correct? I could have added the 1 to the other side and made 0 a function and f of x a function. So when I graph this one, my shift is over 3, so I have an asymptote at 3 still, right? 1, 2, 3. But this time I do have a horizontal asymptote at +1. So then my graph is here and here. Let's make this look pretty. Here and here. Hold on. And then my g of x is at 0, right? Does this give me the same answer? Where do they intersect? They intersect right there at 2, 0. So x is 2. Is that easier? So if you like this way easier, then set it equal to 0, and then you just have to figure out where it's going to cross the x-axis, right? It's like finding your 0, right, with a quadratic function. So x equals 2. Okay, so that's a lot to write. I believe this is your first problem on your homework, so let me get it to you so you guys can get it copied down. How does that sound? And then we'll start working on number 3 and number 4 on the bottom of your worksheet. So for homework, you'll have to do the graphing of the second one, but you'll have an example of how to do it. And then we'll get going on this other stuff. Sound good? All right. And then for some of you, I think I'll put up the notes for what we're going to do next, and then you guys can copy that down as well. In fact, let me just, well, let's let everybody copy this first. Make sure that you can see everything. We're good? Okay, let me pause. Essence want to know why I didn't put a -1 to the bottom if I distributed it to the top, because this is -1/1. So I'm only multiplying the numerator by negative, not the denominator. Multiplying straight across. I don't know if I have it in here. Okay, this one. This is the second one on your homework. When you're solving this, right, you could this is your f of x, this is your g of x. That's one way to graph it. Or you can subtract 2 from both sides. I'm sorry, subtract 3 from both sides and set it equal to 0. And some of you liked it better when one side is 0 and then it's just whatever's on the x-axis. So graphing it 2 different ways. But when you're solving it, you'd have to subtract 2 from both sides first. So you'd have 1 over x minus 4 equals 1, and then you multiply both sides, or multiply by x minus 4 over x minus 4. So that's how I needed to guide you on that one. So now I'm moving on, okay? Now we're going to just solving. So here are your steps to solving. So I'll put the steps up. How about we do the steps at the end? All right, so pencils down. I'm going to talk for no longer than 5 minutes. What time do we have? 46. 15 minutes. I'm going to talk for 5 minutes, and we're going to come back to the steps. Got it? So I want to promise the people that we can have the steps as well. All right, pencils down, everybody. So my first step is I need to factor. Everything up here is already factored, right? Don't need to factor on this one. The next thing I'm going to ask myself is, what are the excluded values? What can x not be? Well, here, x can't be 0. Here, there is no x. And here, x can't be 0. So we're covered by saying that x cannot be equal to 0. All right, so next I'm going to multiply everybody, creating a common denominator. So my common denominator here, common denominator. All right, so I've got a 4, I've got an x, I've got a 6, I've got a 12, and I've got an x. So the factor in here, now what I have to ask myself is, can I make 4 a 12? Can I make 6 a 12? So 12 is my common denominator, but x is also my common denominator. So 12x is my common denominator. All right? So I'm going to multiply everybody by something that they're missing. Okay? So the 4x, in order to make it 12x, it's missing a 3. So I have to multiply this by 3 over 3. The 6 is missing a 2 and an x. So I need to multiply this one by 2x over 2x. And the 12x is missing nothing. So let me go ahead and rewrite it. So I have 3 times 9 is 27, 27 over 12x. 5 times 2x is 10x over 12x. And then I have negative 13 over 12x. I don't quite have equals on both sides. I'm going to combine these two. So 27 12x's minus 10x over 12x is equal to 27 minus 10x all over 12x. Correct? is equal to negative 13 over 12x. Now I have a denominator that matches, right? Matches on both sides. Therefore, I'm just going to get, I could take one extra step and multiply both sides by 12x over 1. You can do that. Or you could just recognize that the denominators are equal, then the numerators are equal. Okay? So this problem just turned into something a lot more simple. I went from this crazy problem up here, right, with fractions, to it's now just 27 minus 10x equals negative 13. It's solving a two-step equation. Okay? So I'm going to subtract 27 from both sides. When I subtract 27 from both sides, what do I get? Negative 40. Then when I divide both sides by negative 10, I get positive 4. Now we can check. Let's see if it works. If I put 4 back in that original equation, it should work. So here's my check. Let's do the check over here. So I have 9. I don't want to make this confusing. I already wrote my excluded value. So I have 9 over 4 times x. What do we know x is now? 4. Minus 5 over 6 equals negative 13 over 12 times 4. 9 over 4 times 4 is 9 over 16. Minus 5 over 6 equals negative 13 over 48. Can I turn a 16 into a 48? By 3? And can I turn a 6 into 48? By 8? Ooh, time's up. Therefore, you could do this with a calculator too, right? And not have to do all this math. So I have 9 times 3 is 27 over 48 minus 40 over 48 equals negative 13 over 48. And if you do 27 minus 40, you get negative 13. And like I said, I would do that with a calculator just to check and see if I was right. At this point, you could have put in a calculator 9/16 minus 5/6 equals, and you put that in a calculator, you're going to get the same decimal. Okay? All right. So there are your steps. That's number 3. You can copy that down on your homework, and then you guys can go to the next one, or I can go to the next one. I can do number 4, but I want to give people enough time to write this down. Your eyes were closed, Chris. Oh, that's right. I apologize. All right, so for those of you that are going to move on, the first thing you need to do, what's my first step up there? Factor. So as soon as